What we'll do is we'll look at different types of problems and we'll find an approach for solving them. Okay, so the first problem you want to solve. You can read it for me. And you're okay with that approach, right?
Yeah.
Yeah. We'll try solving the type of problem, okay, so that you can do n number of problems that you want to solve. You need a cable?
Nice.
It's okay.
Is it ready?
Yeah, okay. Anyway, sure. Yeah.
I tried solving some of the practices,
Okay.
and I had a question. Like, I didn't know how to solve one of them.
Ah, okay. That's good. So you already know what problem you're trying to solve and what problem. And as I say, we will use tran as our method for solving it. Okay.
Okay, so log 2x. So
Log
base 2
base 2
x
x
plus
plus,
log base 2
okay,
x minus 3
okay,
equals to 2.
equals to 2. Okay. This is an easy problem. Whenever you see this, log is always on the basis of some base. If there is nothing written, by default you can assume that it is
10.
10. Okay? So this part you and I understand the same way. Now, look at this. What is the, here the first one. Log 2, again the tran method, okay? T, as long as you trust me as a teacher, you will trust yourself. Now we start with read, okay? Or log x base 2 plus log x minus 3 base 2 equals to 2. This is the first time reading. If I read it one more time, I see log x base of 2 log x minus 3 base of 2 equals to 2. What is that I am finding by reading it multiple times is, these two guys seem from the same family. Yeah, both have log base 2. This guy is the outlier. If I can bring this guy also into the same family, my job becomes little easy. Yeah. Now, what does 2 mean? 2 of anything means 2 into 1. Yeah. Now, 1 I can write the way I want. If I have log 10 base 10, this is 1. So anything, any number with the base of same number in the log gives me a 1. Yeah? I can always write 2 as 2 into 1. That's the easiest thing I can think of. So that means I can write, since everything is log of base 2, I will try to find out this guy also as log of base 2. Yeah? So let me not jump the gun, let me go step by step. So what we found was there is an outlier in this whole equation. Everything was log of base 2. Only this guy is an outsider. And this one I can write the way I want. So what I will do is, since everything is log base of 2, I will also say this. Now, other thing to remember here is, if I have 2 into log of something, let's say log x, base x. What this means is, if I want to make it further simplified, I can write this as log x square, because this power 2 comes here, like what we have learned before. Yeah? So, this is log 2 of 2. I can also write this as log 2 of 2 square. This into 2 went that side. Yeah? Or 2 square, I know that 2 square is nothing but 4. Yeah, 2 square, 2 to the power 2, 2 into 2. Yeah. Now this looks like, I'm not dealing with something which is different. So everything is base 2. Yeah. I don't like log. I want to get rid of log. Yeah, because that's how my calculation becomes easy. Everything has log base 2. Yeah. So I'm getting rid of logs now. Can I do that? Log x base 2 plus log x minus 3 base 2 equal to log 4 base 2.
I thought you could only cross out it out once. Like you can cross out a pair.
No, you can cross out everything. It's like my name to the power 3 plus your name to the power 2 plus your dad's name to the power 5. I will say, okay, fine. That name thing I will take out. Me to the power 3, you to the power 2, and dad to the power 5. So basically, these are, or let's give a better analogy. If I say x to the power 3 minus 2 plus 7 equal to x to the power 5 minus 2x. I'm just making it up. See, my base is the same.
You can cross out the x.
I can cross out the x. Likewise,
Oh, okay.
I am crossing out the log base 2. Am I making sense so far?
Yes.
So, if I take that approach, something that was looking way too complicated has gotten simplified now. So, it becomes x plus x minus 3 equal to 4. Now you can literally play with this. Yeah? You just have to solve for the value of x. Yeah? It will be 7 by 2 or something. Yeah? But before you agree to what I said, let's summarize what we are trying to do. If we have any situation like this, a basic example is, let's say if somebody says, I have 5 apples and 3 oranges, tell me how many apples I have. I cannot answer that. I have to convert apples into oranges or vice versa. Then I can use one unit for measuring them or counting them. Same way here also, whenever you are dealing with this kind of situation, if somebody says, okay, this is 4, this is apple and orange, you have to first convert them into one unit, then you can play with them. You cannot say, I'll go 5 miles and 3 kilometers. You convert miles to kilometer, then count them as kilometer, or convert kilometer to mile and then say mile. So that's here, as soon as what our approach was, we first tried to find the unit. What is the base? Once my base matches, I have a base to start from. Yeah? Okay, this was the first problem. Are you clear with this?
Great.
No, I'm saying this one you are clear with?
Yes.
Okay, now you pick up any sum and try solving it. Similar sum, okay? Pick up another one. Let's see if you are able to solve it with the same approach that we just tried. Any sum, randomly pick. Just be overconfident. Okay? Pick any sum.
Log base 2.
Okay, I'll just throw this guy. I'm done with this. Log base 2
X plus 5.
x plus 5. This is how it is, right?
Yes.
Yeah, okay.
And
Okay.
then minus log base 2 x minus 2.
X minus 2. This is in bracket, right?
Yeah.
Okay.
Equals to 3.
Equals to 3. Now, I will not try solving it. You just look at this sum, read it one more time, Try relating that with what we did just now and see, do you really need me to solve this?
So I can solve it.
Yeah, please. Same approach. I mean, we are just learning approach, right? Then you can solve hundreds of problems with the similar problem. Are you sure this is the right question? Log 2x plus 5 minus log base 2x minus 2. Okay, you try solving it. I'll tell you why I'm asking that question even. To me, it seems like this question is not correct. So I made a mistake. I just kind of told you that this doesn't seem to be right. That might get you biased. Don't consider what I said. Based on whatever approach we followed, just try using that approach to solve it.
I got x equals 3.
X equals 3. Now, tell me one thing. X, is this question same? Log base 2x plus 5 minus log x minus 2 base 2.
Yeah.
Yeah? Equal to 3. Okay? So, x equals to 3. Let's try solving it together. Okay? I'll tell you why I was kind of getting stuck. So, this is log. Okay. So, before I do that, right? I mean, this is again the same approach. I will read and analyze. By reading this, I see that okay, this is log base 2, this is log base 2, this guy is not base 2. So my approach would be to convert this into base 2. Yeah? So let's try doing it. Log 2 x minus 2, and this guy becomes 3 into 1. 1 is log 2 base 2. Yeah? Or I can always say this is log base 2 to the power q. Yeah? Yeah, this is it. Now this equation has been revised to x plus 5 minus log 2 x minus 2 equal to log 2 8. Yeah? So I can strike off all the log base 2, and this becomes x plus 5 minus x minus 2 equal to 8. Why I was asking if this question is correct or not, because what will happen is this is x plus 5 minus x minus into minus plus 2. I'm just breaking this bracket now, equal to 8. There is 1 plus x, 1 minus x, which will get cancelled out. So this becomes an equation with zero solution.
Oh, we were supposed to do it different for this one.
I'm sorry?
I did it differently for this.
Okay.
Because a log minus a log is equivalent to it dividing itself. If it's the same log, then the breakdowners get divided.
That's a good thing. Now I'm just thinking.
And if it adds up, then it multiplies. So
Yeah, so here we are not multiplying. I mean, the earlier sum that we tried solving, we did not multiply them. We we just cancelled out this thing. That approach is also fine, but yeah. So with this approach I cannot solve it for sure. Like what you are doing, let's do that. So it becomes log 2 x plus 5 divided by x minus 2
Yeah.
equals
3.
8. So okay, so it becomes x plus 5 by x minus 2 equal to 8.
Yeah.
So x plus 5 equal to 8x minus 16.
Yeah.
7x equal to 21, x equals to 3. And you're right with that approach. My only worry is solving the same problem gives me two answers. One is giving me no solution option, no solution situation, which gives me 7 equals to 8. And if I do the divide thing, that gives me this one. I'm just thinking. Okay. Yeah. This could be possible. So if you have a situation like this, any sum that you have, what approach you can take is always go the simple approach, the plus minus thing, like a normal equation. If you come across a situation like this where you are not getting a solution, look at the division or multiplication option. You can pick one of the two and give the answer. Both will be fine. Let's pick up another question. Let's see. You're clear with what we are doing, right? I mean, you yourself found the second option, and that is correct. I mean, there's nothing wrong with that, because if you have the same base and it's a minus, like we do plus as multiplication, power as like 3 into 1, and then this is the log. So this goes as a power, and a number goes as the power of that thing, right? So there are three things that we do. So plus as multiplication, minus as division. I think you can do that. That's also fine. Let's pick up another sum and see which way we can do. So our approach would be simple equation. If that is giving me answer, go ahead with that. If it's not giving the answer, you can see if there is a possibility of using the multiplication and division as an option. Okay.
Okay, 4 to the power of x minus 3 equals to 1 over 16. Sorry.
Yes. This one.
Yes.
So this is what we have to solve. There is no log here.
No.
Okay. So this, now you can see 16 is what? 4 to the power 2. Or you can write this as 4 to the power x minus 3 equals what? If you bring this up, what it becomes? 4 to the power, how much? Minus 2.
Wait, what?
It will be minus 2. So it goes like this. Okay. So let's first play with this. Okay. Then we'll be able to. If I say 4 to the power 2, this is clear.
Yeah.
Now, if I say 1 by 4 to the power 2, what does it mean? I can write 1 as what? 4 to the power 0?
Yeah.
Yeah? And this 4 remains this? Yeah?
And then you subtract it, right?
Yeah? So that's what I was saying. So,
Becomes negative 2?
yes, ma'am.
Okay.
Yeah? So, this is what we can see to be confirmed that okay, this is what it is. Now, if you want to play with this, 4 to the power 8 is this. 1 by 4 to the power 8. If I have to bring it to the numerator, I will simply say, I'll reverse the sign.
Okay.
If I have 4 to the power minus 6 here, okay, I can write this as 1 by 4 to the power 6.
Oh,
Whenever I move from numerator to denominator or vice versa, the sign changes.
okay.
Just for the sake of doing it faster. You can always prove it.
Yeah.
I'm saying this is how you can play with it. I have a to the power 16 into a to the power minus 4. I know that it is, I'm just adding them. 16 plus minus 4 is 12. I know that minus 12 divided by a to the power 4 is, this also becomes minus. So it becomes a to the power minus 12 minus 4. So similarly, if you have, let's say, a to the power minus 12 into a to the power 16 by a to the power minus 6 into a to the power 4, you can always say, okay fine, let me simplify this. This is minus, so this guy actually wanted to go down. This is minus here, so this is wanting to go up. So I will simplify this. A to the power 16, because this is minus, I don't want to deal with this. It comes down. Whatever I have here, this is minus, so I don't want to deal with this. It becomes 8 to the power 6. Then 8 to the power 4. Now I can do the calculation. So, simple thing to remember, if you want to save some time, would be whatever be the power in the numerator, if you want to bring that number to the denominator, you will just reverse the sign. Or vice versa. If I have 1 by k to the power minus 17, I can always write this as k to the power 17, because this goes here and we convert. Okay. Now let's come to the question. You were saying 4 to the power x minus 3 equal to 1 by 16,
Yes.
which I can write as 1 by 4 square. Yeah?
Yeah.
4 to the power x minus 3 equals 1 by 4 square. Or I can write 4 to the power x minus 3 equals, let's bring this guy up, 4 to the power minus 2.
Cancel out the 4.
Am I making sense so far?
Yes.
Yeah? So that means x minus 3 equal to minus 2. Can I say so?
Yeah.
Yeah?
Yeah.
Now you can solve it. So log is nothing but another way of calculating numbers with any other number as a base. Okay. Imagine if you have to write $1 million. Log gives you a shortcut. Or you will say 6 log 10, because if I am not mentioning the base, default base is 10. So this is it. Okay. So it's another way of representing the number. It gives you a different mechanism for calculation. That's it. Nothing more. Clear? Any other question of the same type?
No.
Now, what is the second type?
Word problems.
Word problems. Wonderful. I love them. Because word problems are the easiest of the problem types if you read them properly. So let's pick one.
Number 7.
Okay.
Let me pull it up. There's 3 parts to it. So there's 7A, 7B, and 7C. It's all the same questions, but there are 3 things you have to do.
Mm-hmm.
I don't get the last part of it.
Okay.
C.
And before we start, any word problem that you see, right? I have seen all the kids get stuck with word problems, or they feel word problems are difficult. But word problems are like treasure hunt. It gives you a lot of clues. When you read it again and again, you'll get all those clues, and then you will solve it. So don't worry about the word problems as a problem type which is going to haunt you. Look at word problems as a problem that has a lot of treasure hunt within. Good. We'll do it with that mindset, okay? Just read it for me.
So the question is, as of 2018, the
Okay.
world population is 7.616 billion.
Okay.
PT is population in billions of people, and T is time in years. Okay.
P is population in billions, okay, of people, and T is time.
And then it has a growing rate of 1.1% a year.
1.1% per year, okay.
So, and then as of 2018, we have an excess of natural resources that are able to support a population of about 9 billion people.
Okay.
However, the natural resources are being depleted at about 1% per year.
Okay.
When will we no longer have enough natural resources to
Okay.
support the growing population?
Okay. So I think I understood the question, but I will just read it one more time. Can I take
Yes.
it?
It's this.
Okay.
It's C. C is the specific question that I'm stuck on. I
Okay.
did A and B and I got it right.
Okay. So it says, as of 2018, the world population is 7.616 billion. Wonderful. As of 2018. So when we all were 5 years younger, or 6 years younger, the world population was 7.616 billion, and is growing at a rate 1.1% per year. So 2018, the world population was 7.616 billion. So by 2019, it would have become 7.616 into 1.01. This many billions. Yeah? 1% is that, right? So you had 100. 100 is 100%. It increased by 1%. 1.1%, right? Yeah.
Yeah, it's 1.1, but if we have to do if you're calculating by rate, it's like the initial amount multiplied by 1 plus the rate as a decimal.
That's what it is actually. So see, this is, let's say my number is this is my population today, okay, and it's increasing at 1.1%. 1.1 divided by 100.
Yeah.
Yeah.
Plus 1.
Yeah. So this is x plus x 1.1% of this one. So this becomes x into 1 plus 1.1 by 100.
Yeah.
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 And this becomes, this is 100. This is 100 plus 1.1. It is x into 101.1. Yeah. So this if I divide this, I'll move it by 2 digits here. It becomes x into 1.011.
Yeah.
That's what I have written there. But anyways, I'm not trying to prove what I was doing was right. I was just validating if whatever I wrote was correct or not. Okay. Now, oops, it got lost. Yeah. So first part is this line, which says, if I read it 2-3 times, right, it looks much easier to me. It says, as of 2018, the world population was this, and is growing at this rate. It's growing by 1.1% every year. In 1 year, it became this much. Next year, this will be my new number, and into same thing, into this number. Yeah. Write the equation to model the population growth, where PT is the population in billions of people and T is the time in years. So this will be your compound interest formula. Yeah? This is what you would have written. So A is done, correct?
A and B is done.
B is done.
C.
Sorry. B says, what is the predicted population for 2050? So I will use the same formula, right? 2050, I'll just count the number of years. So from here to 2050 is 32 years.
Yeah.
This T will be 32. Good that it's only asking us to write the formula, so which is good. Now the C. As of 2018, we have an excess of natural resources and are able to support a population of about 9 billion. However, natural resources are being depleted at about 1% per year. When will we no longer have enough natural resources to support the growing population? Okay. So, let's see, there are two equations that we are talking about. One equation is when the population is increasing. Second equation when the natural resources are decreasing. So, look at both of them as a compound interest problem. Okay. When you talk about a compound interest, meaning, let's say this is my principal amount today, if this is my rate of interest R, okay, and I'm talking about n number of years, what is my revised number or my new value? If I call that as A equals P into 1 plus R by 100 to the power n. This is the formula for compound interest, right?
Yeah.
Yeah. Here we are talking about two situations, the same thing. Why? Because population is increasing by 1.1% per year. So today if it is 100, next year it will be 101.1 or whatever is that calculation. Right? A year for post that will be, the new number will be 1.1, whatever is arrived, and 1.1% of that. Your base has changed. Yeah. Similarly, for the natural resources, today it is, let's say, X. Every year it is depleting by 1%. So next year it becomes 100 becomes 99. The following year it will be 1% of 99 that will be depleted, not 100.
Yeah.
So let's say how the population is increasing. Okay, so population is increasing by this. Let's say after n years, whatever is the population, that is more than whatever is our natural resources thing. So let's look at what is natural resources calculation. Let's say today we have natural resources for 9 billion. Okay, and let's say after n years, this is less than my population. Let me recollect my thoughts. What we are trying to do here, we are trying to say, after certain number of years, my population becomes certain value. And that value will not have enough natural resources.
Yeah.
So natural resources that can support a population is certain number. That value is less than my new population. Yeah. So let's say n is that year when that situation arises, when my population count is more than how much my natural resources are. I mean, how much my natural resources can support. Okay. So let's say after n years, if my current population is P, which is 7.616 billion. Okay. After n years, it becomes 1 plus my rate of interest is 1. I mean, not rate of interest. Yearly increase rate is 1%, 1.1% to the power n. Okay, this is what my population will become, which will be more than how much my natural resources are. Now, let's look at the formula for natural resources, what the value will be after n years. So today it is 9 billion.
Yes.
It is not increasing, it is actually decreasing. It will be minus by 1% every year after n years. This is what we have to solve. Now, what is this value? 9 into, this is 100 minus 1, 99 by 100 to the power n will be equal to, okay, this is my natural resources and this is my population. And I'm saying this population is greater than this value. Or I'll just write 0.99. 9 into 0.99 to the power n. Yeah? Whatever my population becomes after n years is more than what my natural resources capacity is. Now we have to do this calculation also. This becomes 7.616 into 100 plus 1.1 by 100 to the power n is greater than 9 into 0.99 to the power n. Now this is a, we'll have to find out how do we solve this equation for n. There was one more clue, right? It said by 2050, what was that? Oh, that was just to write the equation for that.
Yeah,
right?
but I calculated it, and by 2050 it would be 10.8 billion.
Okay, that was just to derive, right? Okay. Now here we have to solve it for n. So 7.616 into 101.1 by 100 to the power n equals 9 into, not equals, greater than 9 into 0.99 to the power n. Yeah. So let's bring everything here one side. 101.1 by 0.99 into 100, or I'll take this out, to the power n is greater than 9 by 7.616. So this is 101.1 by 99 to the power n is greater than 9 by 7.616. This is what we have to solve it for. Okay. Now from this, what does the question say? Is it asking you to just get the formula, or is it asking you to solve it for it? Okay. So now, do you know how to solve this one? No. Okay. Let me think how I can solve for power n.
I can solve it if it was equal to each other. I could turn it into x.
Okay, so no, so you can just assume this to be equal first, and then whatever value you get for n, it will be a value more than that.
I can turn it into logarithm.
With logarithm, right? That's what I was just thinking. Log will be the only way to solve it, because when you have to the power n, right?
Yeah.
So you can use base of log 10, right?
Oh no, to convert it, the 101.1 over 99 is going to be the base, and then the 9 over 7.616 is going to be next to the log, and then it's going to be equal to n.
Right. Both ways actually. I mean, you can always choose actually. You can choose whichever base you want to pick and find the value for both the sides with that base, and then to the power of, find out this thing, and then I think log table will help you. That will be the best thing. So here in this case, right, what you will do is you will assume this to be equal to, okay?
Yeah.
And then find the value of n. And it will be always, see, here your numerator is more than denominator, okay? So that means whenever you are increasing the value of n, whatever value you get for equal to situation, anything more than that will hold true for this thing. So let's say here, let's assume that you got value of n equal to, let's say 39. So you will say that for anything more than 39, this natural resources will not be enough to support my population. So you just find the value for the equal to situation, and then you will say my answer will be greater than this. That's the way to solve inequality problem. So when you are solving an inequality problem, greater than equal to or greater than or greater less than or greater than equal to or less than equal to, you always solve it for equal to sign and then put that condition. Let's say if it says less than this and you got 39 as your answer for equal to situation, you will say for every value less than 39, this condition holds true. So be it 38, be it 37, be it 35, be it minus 5, all situation. So that's how we'll solve it. Does it make sense?
Yeah.
Okay. All right. So which one is the next? The younger kids are not here yet, so we can use the time.
Okay. It's not loading. What's the internet? Internet.
Internet? Do you see Spectrum D5 or something?
Spectrum D5.
My classes are of no use anymore. No use now. Spectrum D5. I think this one should be the one, B9.
Okay.
Yeah.
An investment that earns a rate of return or doubles in value in T years.
In 3 years.
In T years.
T years, okay.
Where T equals natural log 2 over natural log parentheses 1 plus R, and R is expressed as a decimal. What rates of return will double the value of an investment in less than 10 years?
Okay. So when I hear this question for the first time, it looks difficult to me. And the only way I can make it look easier is by reading it over and over again. That's what we'll do. So I'm just reading it loud and clear, okay? An investment that earns a rate of return R doubles in value in RT years. Okay? An investment that earns a rate of return R doubles in value in T years. Okay? So they're not talking about simple interest or compound interest. By default, we'll assume that this is compound interest. Then. You know what is compound interest and simple interest, right? I think we talked about it before.
Yeah.
Yeah. Okay. So anything that doesn't talk about simple or compound interest, we'll assume that it is compound interest.
Oh, but they gave the equation for it. You just have to plug it in.
Yeah. Okay. I think once we simplify this equation, it will turn out to be that equation only.
Yeah.
Okay. So I'm just reading it one more time. An investment that earns a rate of return R doubles in value in T years, where T equals to natural log 2 divided by natural log 1 plus R, and R is expressed as a decimal. R is expressed as a decimal. Okay. That is nothing but it will be that rate of interest R divided by 100. That's why it is saying it's expressed as decimal. What value of the return will double the value? What rates of return will double the value of investment less than 10 years? Okay. So let's write the equation. I'm just saying t equals, can you read it for me? 2 of natural log. Yeah?
Oh, natural log 2.
Natural log
I
2.
don't know if that's the same thing, but
So, does it say like this?
yeah.
Okay.
And then natural log parentheses 1 plus r. Yeah.
Okay. I'm still trying to read the question. I'll have to read it one more time. Okay. An investment that earns a rate of return R doubles in value in T years. Doubles in value. Doubles in value. Okay. So let's say if I had initial amount as A, it doubles in value in T years. After T years, it became 2A. Yeah? Rate of return is R in value in T years, where R T equal, okay. Now, this is saying the relationship between T and R. T and R, how are they related? That's what this is saying. Okay. So here, what we can say, T equals what?
Oh,
Log 2 okay, log 2 minus log, should I want to do that way, or okay, or I will, Ishan, pick a chair, sit down, 5 more minutes. So what I can do is, I can say then one, oh sorry, I'm just thinking how we can make it more simple. Let's do one thing. You give me this sum also. I have to recall. Hey Gaushika and Kavya, pick a chair, sit down. So let me do one thing. The natural log thing, I'll have to just revise quickly, okay? I had not looked at that one. And send me a picture of this one also. Just this whole sum. Take a copy or picture of that and give it to me. Because natural log one, I have to just kind of redo it one more time, and then we'll be able to relate that. So let's try doing this in the class tomorrow. So apart from these two topics, is there anything else that we are missing?
no.
No. And here there are two sums. One sum with the natural log that we had given before, and this one again.
Yeah.
These two are relatable, so I should be able to just spend 15 minutes and then we can go through it. In the meantime, before the class tomorrow, I would suggest just look at the other set of questions that you have, and if there is anything else that you would want me to, that we can work together in the class, just let me know. So we have two sums already to solve, but two will be just too quick. I mean, once we look at the natural log thing, it will be like 10-minute thing, right? So look at any other question that you would want to kind of brush up, or try solving a few more sums by yourself and see if you are getting stuck anywhere. Okay? And then we'll meet tomorrow. Yeah? Okay.